Several years ago, when bird flu H5N1 hit, I reported on it immediately and provided several updates over the following 24 months. I did this not because of the numbers of people affected, many more birds died than people, but because of the deadliness of the microbe. The bottom line for avian flu was, and at present is, that it has problems jumping from birds to humans, and when it does, it's quite deadly for those humans, which prevents its spread to other humans. So it's been generally self-limiting. Compare this with the recent swine flu H1N1. It passes much more easily to and among humans, but it's not particularly deadly in its current form. But these viruses, whether bird or swine, are always changing, always mutating. So we have to understand what they're doing biologically in real time and stay one step ahead of them. And that's exactly what the CDC is doing with the current swine flu. Here's what we know about H1N1. This bug is pretty good at keeping itself alive by invading our nasal mucosa and spreading to others when we sneeze. Walter Dowdle, a former chief of virology at the CDC, describes the H1N1 as a real mutt, because genetically it's a mix of swine, human, and bird genes. The genetic structure of these viruses aren't enormous like in humans. Their entire gene library consists of just 8 short strands of RNA, which in turn directs the production of only 11 proteins. They invade a cell, break apart, reassemble, and depending on their chemistry, may or may not destroy the cell. The reason that H1N1 is currently relatively mild is that it lacks the genes to produce 2 proteins that cause havoc for humans. The first, PB1F2, weakens and destroys cell mitochondria, the cell's energy manufacturing sites. The second protein, NS1, attacks interferon, which is critical to an effective human immune response. Now, up till now, these proteins have only been found in bird flus, and experts say it's unlikely that the current swine flu will go in this direction because it's never happened before. What's more likely is that the swine flu, when it returns this fall, will have become resistant to Tamiflu. The world's stockpile of the antiviral Tamiflu has been in response to the threat of bird flu H5N1. Over the years, most seasonal flus quickly develop resistance to Tamiflu. If that occurs, doctors and their patients in the U.S. will likely rely on another antiviral, Relenza, which is more expensive and must be taken with an inhaler, or they'll use older drugs like Romantadine, which have resistance issues all their own. What we know for near certain is that we've not seen the last of H1N1 swine flu, and thus far it has spread fairly rapidly, but without enormous human death and destruction. Thanks to concerns about bird flu, we're more vigilant, have better testing, and take these threats very, very seriously. And that is as we should. For Health Commentary, I'm Magee.